Today, we are going to understand how to calculate and draw the efficiency map of a 100 kilowatt PMSM drive. The power losses of the PMSM motor, including copper loss and core loss, can be obtained from the GMAG-RT model, and the power loss of the drive, including switching loss and conduction loss, can also be obtained from IGBT thermal module during the simulation plus the junction temperature. At the end, the PMSM drive system power loss and efficiency can be easily calculated from the power losses of the PMSM and its drive. This is indeed what we are going to do in this video. As you may know, the efficiency map of a motor drive system is an important output as it gives system engineers a nice picture of the overall efficiency of the drive and what operating point to operate at for maximum efficiency. The generation of the efficiency map of a PMSM drive system could also ask some extra effort and time because it involves comprehensive load testing of the complete PMSM drive system with a motor dynamometer. The workload, time, and cost prohibit such activity most of the times. So the alternative way to obtain the efficiency map of a large power PMSM drive system is often through simulation. In our case, we will use GMAG-RT plus PSIM. The script programming code from PSIM can also help to automate numerous simulation without user intervention for generating efficiency data of the PMSM drive system. So the motor control design suite and automation script features make this task very easy. For that topic, we will use the template PMSM directly here. PMSM IPM drive GMAG-RT torque control and the script called efficiency map speed torque limit that I will show you later. So several major steps are needed in order to obtain the efficiency map of the PMSM drive system. First, we have to create an operational torque control system for the PMSM motor drive. Then we have to use a thermal module of the inverter to obtain the IGBT power loss and also add efficiency calculation. Then we have to run the script code to sweep the speed and torque and automatically simulate the motor drive at different operating points and obtain the efficiency map of the drive system. And finally, we have to plot the efficiency map. Now let's have a look to the template open. We can see on the top the power stage of the circuit, including the DC bus of the system, the inverter model for thermal aspect, but also the PMSM from RT model, and also the constant speed, which is in fact the mechanical load. We have at the bottom the complete control stage with some advanced control algorithm. So indeed, the control is using a torque reference that we will inject into our advanced control block. Also, the torque, LD and LQ are extracted from the RT motor and they are fed to the control block part, which are here. We can finally see the main parameters defined and needed for this simulation, like the voltage source, the DC bus, the switching frequency, the maximum current for the inverter, the constant speed load, the motor parameters, and motor controller parameters. And of course, all these parameters are called again into this parameter file here. Also, you have to decide the proper values of the switching frequency here, the sampling frequency of the current loop, the sampling frequency of the speed loop, but also you need to choose the good value for the crossover frequency of the current and crossover frequency of the torque. So typically, FCRI should be chosen like the sampling frequency divided by 10, and the FCRTE is chosen like FCRI divided by 10 as well. Of course, you can still adjust those values depending on the speed of the loop that you want to design. But in our case, we have defined the value like this. So here we have divided by 20, this value, and here we have divided by 10, this value. And also, one key simulation waveform to watch is the modulation signal VMA at the input of the PWM block. So the waveform VMA should not be out of the range of the carrier wave, named V3. So in our case, we have set a value to 1. So the signal should be between 1 and -1. Don't forget to also click on the speed torque curve button, because as you may know, this button will give you a very quick overview of the maximum torque and power that you can achieve depending on the speed of your motor. So in our case, we are still in MPTA before 4,000 RPM, and then we go into field weakening. So basically, click on this button and you can see which torque and power you could expect, depending on the parameters you have filled in. Of course, you can still modify the voltage and the current, for example, and you will see the modification applied automatically if you click again into the speed torque curve button. Once you are filling all the needed parameters based on your specification, don't forget to click on Update Parameter File, and this parameter file will be updated. So basically, click on it, and you will see that all the needed parameters for the controller will be automatically calculated. Then the simulation is ready to run. It's important also that the system is functionally stable and has reached the steady state. Then we can validate the functional and stable motor drive system. Also, we have made some changes in the schematic. So the inverter. This inverter is based from the thermal module for loss calculation. So you can select directly the device that you want to use from the thermal library. Also, we have selected this Infineon model, okay, for the inverter, and two hybrid pack connected in parallel. Also, we have added a circuit to obtain the motor power loss from the GMAG-RT model. So the motor copper loss and iron loss are obtained from the GMAG-RT directly. And we have added a low-pass filter at each power loss output to smooth out the waveform. Also, we have added a circuit to obtain motor torque from the GMAG-RT motor model. So the motor developed torque is also obtained from the GMAG-RT. This torque contains a significant amount of special harmonics, and again, a low-pass filter is used to smooth out the waveform. And finally, we have added an efficiency calculation circuit to obtain the motor drive efficiency. As you can see, you can go directly inside the block and you can see which calculations have been done in order to obtain the different efficiency drive, motor, and inverter. Now let's run the simulation. Once the simulation is done, after clicking on this button, you can directly show the main signal to check. So basically, the waveform shows the startup transient of the 100 kilowatt IPM drive from 0 to 160 Newton meter at the speed of 6,000 RPM. So we can see the constant speed, which is 6,000 here, and we can see that the torque of the motor is achieving the reference command, which is around 160 Newton meter. We can also see directly the VMA, which is always between 1 and -1. And also we can see the efficiency, which reach around 95.6%. So if you zoom in directly, you can see the value of the efficiency. And you can see the efficiency is 96% directly. So the efficiency of the drive is very, very accurate in our case. Once this job is done, we can definitely automate the simulation by using the script code and finally plot the efficiency map. For that, we will need to sweep the torque command and the load speed and record the efficiency automatically. So let's open the script right now. So we have the script capability into PSMM, and you can directly load the script that I have open directly from there. Here you can see all the scripting, all the lines which are needed to run the simulation and plot and create the efficiency files. So basically, in this example, the torque command, which is TE command, is set at 20, 40 until 200 Newton meters. And the constant speed, which is NM load, the NM value here, is set as 1000, 2000 until 9000 RPM. For this example, a total of 90 simulations are required to capture the complete system efficiency data over the entire speed torque range. And this is a big and time-consuming task. So PSMM script function can be used to automate the process. So this script code named efficiency map speed torque limit is prepared to run all the simulation, record the efficiency map data of the drive, motor, and the inverter, and also it will create 3 MATLAB files for plotting the contour maps of the motor, of the inverter, and of the drive system efficiencies in MATLAB directly. But before running the script code, we need to disable the speed and torque command from the parameter file as we want to sweep them by using the script. So just you have to directly open the parameter file and disable by adding some command like this. And you can directly now run the full simulation only by using this script. So you have just to click on run script, and at the end, after waiting a couple of minutes, you can directly see different file which has been created. So 3 files have been created here. So as you can see, after automated simulation, 3 MATLAB files will be created and contain the efficiency map data of the drive system, of the motor, and the inverter. Then we just need to launch MATLAB, as you can see right now, and load and run the different file. So the next step is go back into your main folder where are the main efficiency map, and just drag and drop into MATLAB. Wait a couple of seconds, and the different efficiency map will be drawn automatically. So I will repeat the other steps for the inverter. So here, this is a drive. Now, this is the inverter. And the next step is the motor, of course. And now we can see the different picture So now, if I just go back into PSIM and show you the different pictures, we can make a quick conclusion. Okay, so I will just put them like this. Okay, we have indeed here the motor, the inverter, and the drive, the overall system. So we can easily conclude that the highest efficiency region is when the speed is between 5,000 and 9,000 RPM, and the torque is along the limit of the speed-torque curve that we have defined before. Of course, if you want to get, again, better accuracy, we can sweep more speed and more torque into the script in order to get thinner resolution. But definitely, you can see here that the best efficiency is close to this region for all of the curves here. So the conclusion, we can say that with the motor control design suite, the GMAG-RT motor model and the script function into PSIM, the process of generating the efficiency map of a motor drive system is very easy for the user. That also gives the advantage to motor designers in evaluating the motor performance in a motor drive environment, and also helps system engineer in determining the optimum operation of the motor drive system.